Hello everyone, my name is Leah Kopke and I'm a 3D motion design freelancer. This is my 3D modeling podcast, Ambient 3D Animations, and I'm super excited to show you how to create these paint-like, liquid-like simulations. I actually used Pyro for these, so I'm going to show you the entire process for how you can make this yourself if you'd like to inside of Cinema 4D. So let's go ahead and get started. Here we are inside of Cinema 4D. I just like to run through the setup of my scene really quick. I have these 3 spheres over here. I'm going to actually delete these emitters off of them so that we can start from the beginning together. But I have these 3 spheres that are just primitives, and I place them on a cylinder that I named pedestal. I set up a redshift light to the right. I set up one here to the left as well, and I have this big fill light here to just get rid of some shadows, and I have all of these under my lighting null here and name them accordingly. I put in a backdrop. You can also find a backdrop in your settings here for your primitives and your primitives drop down. So that was the basic setup, and I also added in this camera, and this is the camera perspective in here. I'm just going to move in the camera a little tiny bit and hit save. So this was how I started out the scene. I added just a basic white material here. I have these 3 different colors for the different spheres, so you can create your own redshift material in here, adjust the color to something fun in here like green, and then increase the roughness if you want. You can choose whichever 3 colors you'd like. I'm going to stick with the 3 that I had created here for the spheres, but I made these so that when I create the Pyro and create the mesh from the Pyro simulation from the voxels, that I can make these also the color of the density and have those show up ultimately in my mesh, like in this example. So what I had done is I just added the light blue color to the sphere here. I added the dark blue color to this sphere, and the pink sphere is this one, so I just added those materials there, and now they're all set up, which is awesome. The next step is we need some Pyro emitters. So I'm going to right click on our first sphere, go down to simulation tags, and add in a Pyro emitter. And as I add that in, I automatically also get a Pyro output. Right now we just need the density, so I'll make the density on so that we can preview it in the viewport. And I'll preview the color, so I'll turn on the color. I'm going to turn off the temperature and turn off the velocity because we don't really need to export those for this workflow. So that's what we need to preview. If you choose on export, that's what will be exported out if you cache it out, and we'll talk a little bit about caching in a bit. On is helpful for previewing in your viewport. So I'm going to hold Control and click on this, and I'm just going to add it to the other 2 spheres. So now they all have an emitter, and that's a great start. We have the density enabled. We also need to enable our color. So I'm going to enable the color for all 3 emitters. And the next step would be to give them some fun colors. But just so that you can see how they look initially, I'm going to have the start at frame 0. Just to show you how these look initially, I'm going to hit play so you can see what the Pyro emitter looks like in our scene with the default settings basically. So there's our fire. Very fun, very exciting. Something that I find is helpful for seeing the actual color of the density is I like to just add in a Redshift sun and sky rig. Now I won't be rendering with this, but it does make it easier to see the color of the density in here. and we're going to be adjusting the color of the density in order to drive how the simulation will look. So what I like to do is match the density to the emitter that we're using. So this pink sphere, you can actually right click on your color, hit copy, and then you can go into the emitter, Pyro emitter tag, so I'll click on that, and then go down to color, right click on the color, and hit paste. And then that way they're the same color. And it makes it a whole lot easier. Now if I start this at the beginning, you'll see that pink sphere is now emitting pink density, which is pretty cool. Our smoke is now pink, so that's pretty good progress to me. And we're going to do that for the other two. So I'll right click on this light blue color, copy, and I'll paste it within the color enabled color here, paste. There we go. And then we'll do the same thing for the dark blue. We'll hit copy and we'll hit paste. Right click, paste. So now we have all three, but in order to see that, we need to start this back at the beginning. So I'll hit go to start. Here we are. We'll hit play and we'll get a nice little preview. Now, the thing that I think would make this more interesting would be to have some forces in our scene to push the smoke around and have them mix a little bit more of these different colors. If I come out of the camera and rotate around, you'll be able to see the teal in the back. My computer's lagging a little bit since I have these simulations running. There's this teal one back here, so you can see they're all emitting the color we had added, which is super cool that we can get colored smoke in here. And we'll also need that force we were talking about. So simulate menu, forces, and I added in a rotation. In order to make sure that your simulation is looking similar to mine with the rotation, there's a few settings I had adjusted in the scene settings, and I'll go ahead and show that. The rotation pushes the smoke and makes it speed up a little bit in some ways. So you actually need more calculations happening in your scene in order to have the smoke look smooth when you add in the rotation. So the way to go to your scene settings quickly is Control D or Command D for Mac. So I'm on a PC, so for me it's Control D, but if you're working on a Mac, it's Command D. And then you go into your simulation tab, and then you go into the Pyro tab within the simulation tab. I know it's a lot of settings in here. I actually covered quite a lot of them, so if you want to check that out, I will leave the Pyro simulation playlist where I go through all the settings for Pyro if you want to check these out. And here I had adjusted the voxel size. So these Pyro simulations are actually made up of voxels, which are like these little tiny 3D cubes that make up the form of the simulation. So the smaller this is, the longer it takes to calculate, but it also makes your simulation a higher resolution. So this is like controlling the resolution of your simulation. If I made this really big, a really big number, it wouldn't look as nice. The next thing that I did was I adjusted the min and max substeps. So this is how many calculations are happening per frame. So mine is set to 16 for the max substeps, and that just means if Cinema 4D, as the smoke is moving fast, needs more simulations per frame, I'll allow it to go up to this number. But if it doesn't need as many for a frame, it can go as low as 1. So I'm giving Cinema 4D a range for this calculation. The more substeps, the longer it takes to calculate. The lower the substeps, it goes quicker, but your resolution or those calculations aren't going to be as accurate for the density or the simulation in general. I also adjusted the expected advic distance. So that's basically giving your simulation more padding, more space to grow into something larger. So I increased this up to 16, thinking I want this fire simulation to be a little bit bigger and I want to give it space to grow. Again, the higher the number this is, longer calculation time, but you need to figure out what works for you and is good for your project. I have episodes going in great depth into all of these topics, and I'll leave a link to them in the description in case if you want a more thorough explanation. A lot of people watching have already heard those, so I won't go too into depth, but that's the basics, and that's what I had adjusted in here for my scene. You can play around with these and see what works best for your project. So we have this rotation added in here with our settings set up. And right now it's facing this direction. If we start this at the beginning and press play, we can see what direction this whole thing is rotating. And I'm actually going to increase our angle speed to 100, and I'm going to change our mode to force. That'll change how it looks, so I'll start back at the beginning. So we want this to be a force acting on the simulation, and I wanted greater strength, so I increased the speed, but you can see our rotation is actually rotating the wrong direction. So there's a few things that I want to do in order to correct this. I mean, maybe if you like how this looks, you want to keep it this way, and that's fine. You know, you're an artist. Do what makes you happy. Explore, create, be experimental. I did not want this look, so for my project, what I had done is I had rotated this 90 degrees so that it rotates in a different direction, but you'll see that I'm having this issue where I'm rotating it, but we're not actually seeing these handles rotate. So I'm going to hit undo, and you'll notice that I have this coordinate system turned on up here. You can turn this on and off using W, and if you turn this on, your axes of whatever you are moving will be aligned to your origin, and that can be helpful sometimes, but in this case it's easier for me to rotate this if it's off, so I'm going to turn that off here for a moment. I'll move this on up about 90 degrees, start it at the beginning, and we're gonna see what we have here. So you can see these are turning a little bit more in the other direction. The smoke is mixing. We're getting some cool mixed density looks. And I'll let this keep playing for a minute here so we can see what happens. And how large this simulation also gets is helpful to see in here. Helps you figure out how you want to frame your camera around the simulation. It's good to wait a little bit and see what it grows into. It's all a part of the process. Now keep in mind that my computer's running a lot of it's running a lot of calculations for the simulation. And since it's running a lot of calculations for the simulation, it is not running at real time. Your smoke will be moving faster than this. So you can see my frames down here at the bottom. In reality, this project is 30 frames per second. So by this point, 3 seconds should have already passed in terms of animation time, but in terms of real time and calculation time, it's a whole lot longer. So again, that's why you want to be careful of your voxel size and your sub steps, how many calculations happening per frame, and all of those little details so that you have a reasonable time to preview your project here. So I think this is looking okay, and the colors are mixing nicely. You may be wondering how this turns into a mesh at some point that looks liquidy. So I think a good point to show you how that happens is right now. we were talking about how these simulations are made up of voxels. These little tiny 3D cubes that make up the form of the density of everything in these Pyro simulations, all made out of voxels. And most things, like, let's say this handy little cylinder here, if I turn on quick shading lines, you'll see that the cylinder and even this backdrop, they're made up of polygons. And this is made up of little voxels. So we have polygons here and we have voxels here. And you can see they look a little bit different. But we need these voxels to become a mesh like this cylinder. So how do we do that? Well, the way we do that is how we do it in other situations inside of Cinema 4D. You can actually use the volume builder and the volume mesher with Pyro, because these just convert voxels or work with voxels. And we are working with voxels by working with Pyro. Now, the one that I really need today is the volume mesher. Some enjoy putting the volume builder in the, or putting the Pyro in the volume builder to adjust it. I like using the volume mesher. You could use both of them together. In the manual, it says you can use both. I like this one, so that's what I'm going to use, is the volume mesher. And this turns voxels into a mesh, like what we have for our cylinder, our backdrop here. So there we go. Now, in order to have this work, you might be thinking, do we drop the spheres with the emitters in there? We actually want to drop our Pyro output inside of the volume mesher. Now, this is the part that I find a little bit annoying, is that sometimes it's hard to see the mesh with all this smoke here. So I like to go into the settings for the Pyro. So again, our project settings are Control D, so we'll open these up. Simulation tab, Pyro tab, we're going to scroll down to the bottom. And I do cover all of these draw settings also in another episode. I won't be going super great in detail of these. But the one that I need to adjust today is I need to turn off this draw Pyro. And now we can see our mesh. And you might be saying, Leah, why is this mesh so small? And in comparison to that Pyro simulation. And that is an awesome question. And when I was first playing around with this, I was asking myself that as well. But then I remembered that you can adjust the voxel range threshold in your volume mesher. So the smoke, the density simulation, some areas of that smoke is more dense than others. So this is saying at what density should we recognize this smoke as a mesh, or recognize these voxels as actual data to create a mesh from. So that's this slider here. So if I decrease this, we're adjusting that threshold, and you can see we're seeing more and more and more detail from that fire. So you can get a pretty big fire here, or a pretty big mesh here from our fire. I'm going to turn on garage shading, because this is a dense mesh, so it just ends up looking really dark from all those edges in here once it becomes a mesh. So you could see what this is looking like, and it's pretty cool. And something that I like to do is I actually like to keyframe the voxel range once I find something that looks nice, because I notice that I like to have it at different amounts at different parts of the animation in order to control it. At 0% it looks like this. I think it looks better with a little bit less. Maybe I'll try 3% and see what that looks like. I like how 3% looks, so I can keyframe this here. And then we'll go back to the beginning. And I know this isn't cached out, but we're just getting an idea for what will this look like? What does this look like? What do we like right now? So you can also adjust it here. Let's see what 0.1 looks like. 2, 3. Oh, I kind of like the 9% here. So this will, as it goes, it'll change from that percentage we keyframed here, 9%, and it'll adjust to a smaller amount later on. So it's slowly adjusting between those keyframes. You can even adjust the curves for those keyframes if you'd like. And the point is just to get it to the point which you'd like. You'll notice that some parts of the simulation look a little bit janky. I remember I had one art teacher that used the word janky inside of sketching class, and ever since then I started using it, so I don't even know how how that happened, but sometimes you start using the words that other people use. Anyhow, so right now I have this in here and it looks kind of funky. Like you can see the voxels a little bit in here. And it's not completely smooth. We have these jagged edges, so I like to fix that. I don't like how that looks. And the way I fix that is I go into here, I grab our handy smoothing deformer. Maybe I'll cover these tools in greater depth if you're all interested in them, like the smoothing one. I haven't covered that yet on my YouTube channel, but maybe I should. If you're interested in something like that, let me know in the comments. And I find that the deformer works better if we put both of these, the smoothing deformer and the volume mesher, in a null together. So I like to do that with Alt-G rather than clicking the null button here and then manually adding them in there. So the hotkey that I use for that is Alt-G. I believe that's Option G on Mac, whatever is the equivalent to the Alt button. And then we get this a little bit more smoothed out in here. So you could see that we have the smoothing in here, and you can adjust the smoothness with the slider. So you can see this is what it started off as at 0%, and then as we smooth it out, it becomes a lot nicer. You can also smooth this out even further by reducing the stiffness in here. So I'm going to take the stiffness down to 0. Now if you want this to be smoothed out even more, you can increase the iterations. Now keep in mind that if you increase this further, it's just more calculations and you might slow down your computer a little bit. I'm going to right click on this left arrow to set it back to the default. There we go. Now that we have that set up, I'd like to talk a little bit about how to cache out your density and color information. So let's go ahead and take a look at that. In here, you'll see we have our Pyro output in here. And we were talking about having the density and the color on. Usually when I export this out, just to make it export out a little bit more quickly, because all I really need is the Pyro output and not the smoothing or the volume mesher. What I'll usually do is turn off the volume mesher and the smoothing. Just turn off things in your scene that aren't relevant to the simulation, basically. And once you do that, you can go ahead and choose which one you'd like to export first. So we actually need to export out the density and the color separately. So first we just need to export out the density, so I'm going to turn off the color. And you'll notice that it's no longer previewing in here, but that's okay. Previewing in your viewport. in the cache tab of your Pyro output, and by the way, I have an entire episode going through all the settings in here, so you can check that out on my YouTube channel. Again, that's in the Pyro playlist. I'll leave a link to it. In the cache here, we'll need to cache out this project. Now, you could see that it has this $PRJ, and that means that it'll name the project files, the VDB files, because it's going to export VDB files which hold voxel data. It'll be named after the project and then the frame. So that's what that's saying. But if you want to add something else to here, like if you want to name this project and then have density and then add in another underscore and then frame, you could do that. And then once you have that all set up the way you'd like, you just need to hit this cache button. And it'll say store VDB files at project location, and you can select what you want. I am actually going to just show another project file where I already had cached these out as an example. But if you were going through this process yourself, you could choose to store them at the project file by choosing yes, or the project location by choosing yes. You can also select no and then manually choose a location for your files, which is what I prefer. I find it's better to also add your caches to something on your physical hard drive of your computer, because if you add it just to the cloud or that, it can be hard and dependent on your internet speed, how quickly you're able to download each VDB, because it makes a VDB file for every single frame. So you can imagine how that'll really slow down the process if you have to wait for your internet to have that preview on your computer. So yes, definitely back up your VDB files on the cloud, but make them so that they're easily accessible without relying on your internet so that you can work quicker. So do both. Is my recommendation. I'm going to click no and just cancel because I'm not going through that process again since it takes a long time to cache out. But that's how you would set it up. And then as soon as you're done and you run through that, you'll want to cache out it again and make a secondary cache, but this time in your object settings you want to change from on export for your density. You want to turn that off and then just export out the color data. And then you do the same thing again, where if you want to go ahead and name this color, let's say, and then you can add it to a folder called color, and then you hit cache again, and then it does it, and by the end of it you'll end up with a file that looks a little bit more like this one. So you could see I made the group in here, I smoothed it out, I added in a volume measure. The one thing that I did differently in this was I made the spheres a different material. I'm going to actually put them back to the one we used in the last example so that it looks a little bit closer to what we had done. So this is going to be the color of the spheres now. Oops. Instead, and you'll see that my Pyro, I'm actually going to also delete those two, just for right now. So we're back to the beginning of where we were before. Okay, so you'll see here that I actually have two cached options. I have this one here, and that's my density, and I have this one here, and that's my color, and I can choose which one is being used for this situation. So you could see the setup's pretty much the same. We have the rotation. We should have the same settings in here, which we do, same min-max substeps. Everything's the same. I just had cached it out. And maybe the rotation was positioned a little bit differently, so this one might look a little bit differently in that sense, but otherwise it's same process, same lighting, same everything. So I'm going to go ahead and start this at the beginning and press play. I'm going to delete this material off of here. And you'll see we have our simulation showing up, and it's cached, so it's playing much quicker now. So that's looking good. And what if we wanted to add a color to it? So there's a whole process for that. I'm going to delete this tag since we're starting completely at the beginning, and I'll show you how to add in a color tag in a moment, because that's what we really need. But I'll preview this one so you could see how it's looking. And these were actually the VDBs that I had rendered out. For this project. So the thing is, we actually need 2 of these Pyro outputs. You'll notice that the icon of the output changes a little bit once you cache it out. This just means it's using a cache. If I turn off the enabled cache, you'll see it goes back to just that fire icon symbol. If I turn it on, it changes to the cache symbol. I need another one of these because I'm going to use that to drive the color of the material, the Redshift material we're about to make. So I'm going to copy, and then I'm going to paste, and now we have 2 Pyro outputs. But this one, I'm going to, instead of using the density, I'm going to choose color. So we're using the color data here. Now you can see that show up, all our color. We're using the color data here in order to drive our material. So we're going to need a new material. So create a material, a standard material, and I'm going to name this Pyro Color. Okay, I'm just going to drop this on our volume measure. So somehow we need to get this color data into our volume measure. So it's going to be a little bit of a process. To start off with, we're just going to click on this material. We're going to need a vertex attribute. So I'm typing that in here, and I see this here, so I'm just going to drag this into here. So I'm going to connect this to the color. And right now we need to add information into here so that it knows what color is being added to this mesh. Right now that's missing. So how are we going to create vertex data from our Pyro? And by the way, I'm going to name this color just so that we are less confused as we're working. So we have Pyro color, Pyro density. Nice and neat. We're going to need to right click on this, and under other tags we're going to need a vertex color tag. And interestingly enough, you can drag and drop your Pyro color output into your vertex color tag. And this is where things get really exciting. You can almost see color, but you can't. So why is that? Well, we still need to tell Cinema 4D that this vertex color is driving the vertex attribute. So now we need to drag and drop this vertex color tag into here. And then you can see that our colors are mixing now, and we have color data controlling our mesh, and it's super exciting, especially if you're nerdy like me. And yeah, I thought this was pretty cool when I learned how to do this. And I spent some time reading the manual and messing around with the settings and things like that to use a combination of my own knowledge and what I read in the manual to kind of come up with the entire workflow. So some of it's stuff that I learned from the manual, and some of it's stuff I learned from just playing around with the settings, the combination of the two. And yeah, it looks pretty cool. And then you can render out your project. Another cool way that I had tried this out was this liquid water material. So you can actually find that in your asset browser. If you look for under materials, liquid, you'll see all these different liquid materials. And I just grabbed one of these, liquid water. I think that's the one that I used. But you could try out different ones. You could make this look like orange juice if you wanted to. Let's see what that looks like. I haven't tried that one yet. That'll be interesting. I'm going to drag that on here. What does orange juice look like? I don't like how the orange juice looks as much. I mean, it's interesting, but I think that the water looks more cool. So that's the water. And then you can even change the spheres to be the watery color too. And then it looks like a big ocean wave. It looks like you're doing a liquid simulation, even though you aren't doing a traditional liquid simulation. And then anytime you change your mind and you want to go back to the paint splatter look with the Pyro color material we made, you can always go back and adjust the colors accordingly, and it'll update by frame. I'm going to turn off the IPR here for a moment. We could go to another frame, like let's go to this one here. I'll just click here. It'll take a little while to update. Now that's done it, we can hit start IPR just to show how this changes per frame based on the data. And those VDBs are driving the data for each single frame once you cache it out. So that's how you're seeing what you're seeing. So that's how it looks on this frame. And yeah, you can go ahead and render these out using Redshift. You can adjust the threshold to whatever you'd like. 0.01 is pretty good. If you aren't sure which one to use, if you go back on the basic tab, you can see low, medium, high, very high. Just keep in mind the more you bump this up, the longer it'll take. You can turn on your denoising if you'd like. I like to use Alt single to denoise. You can choose how many frames you'd like to export out. You can choose all frames and get out a whole entire animation. You can choose what format to use and where you're going to save it to, what you'll name it as, and all of that good stuff. And then when you're done, you hit this render button and you get a pretty render. If you have any questions though, please feel welcome to leave them in the comments. I'm happy to help out. I know this is a lot of settings and a lot of information, and that's why I break up a lot of this information into episodes that just focus on one tool or one setting inside of Cinema 4D, so that if someone has a question about that, they could really figure it out in greater depth. This is a little bit more of a project-based video on a specific workflow, so I'm focusing more on explaining that than every single individual setting. But if you do have a question about those, you can either probably find it in another one of my videos, or you can even comment down below, and I'll keep an eye out for your comments and do my best to answer your questions if you run into any trouble. But that's basically the workflow. If you really like this episode, please give me a thumbs up. I always appreciate it. If you haven't already, hit subscribe, ring the bell if you'd like to be notified when the next episode comes out. I really always appreciate it, and it means so much to me to see all of you supporting this YouTube channel. I find it a lot of fun doing this, but your support really does help keep this channel continue going. So I hope to see you here next time on Ambient 3D Animations, and I'll see you soon.